Welcome, dear traveler of the night sky. Tonight, let us journey together into the heart of mystery itself, into the abyss where even light surrenders. Black holes are not merely objects, they are questions written into the fabric of the cosmos. And perhaps the most haunting of all is this: what lies on the other side? Close your eyes if you wish, and allow the rhythms of science and wonder to guide you. The universe whispers secrets through the silence of black holes, and tonight we'll listen together. Imagine drifting through the dark sea of space. Ahead of you, a black hole spins silently, a perfectly round shadow against the backdrop of stars. Around its edge burns a glowing halo, light itself trapped in a desperate orbit. This is the event horizon, the threshold between what we can know and what we cannot know. Scientists describe it as the point of no return. For anything that crosses, there is no turning back. Not for matter, not for light, not for time itself as we understand it. It is less a surface and more a boundary drawn by physics, a curtain that closes upon the stage of the universe. Crossing the event horizon would be unlike anything we can truly imagine. To an outside observer, you would seem to slow down, your movement stretching out across eternity, frozen in a final moment of descent. But from your own perspective, you would pass through without even noticing. No great flash, no shattering moment, only a subtle shift, like stepping into a dream. This paradox, the coexistence of two realities, reveals the strange fabric of space-time near black holes. Time dilates, space curves, and the ordinary rules dissolve. The other side of a black hole begins here, at the silent gate of the event horizon. Beyond the horizon lies the singularity, a word that carries both fear and awe. The singularity is the point where equations collapse, where matter is crushed into infinite density, and our laws of physics break apart like fragile glass. What does this mean? In truth, we don't know. Some theories suggest the singularity is a single point, infinitely small, holding the mass of stars. Others argue it is not a point at all, but a region where space-time is curved so tightly that no known description can hold it. To imagine it, picture gravity pulling without limit, compressing everything, atoms, particles, even the fabric of time itself, into a place smaller than imagination. For physicists, the singularity is not just an answer, but a wound in our understanding. It is a reminder that Einstein's general relativity, as brilliant as it is, may not be the final story. On the other side of the singularity may lie nothing, or perhaps something so different that we cannot yet conceive it. Another universe, another dimension, another beginning. The singularity, then, is not only an end, but a question mark shaped like a tear in spacetime. If black holes devour everything, could there exist the opposite? Something that only gives? This idea leads us to white holes, the mathematical mirror twins of black holes. In theory, a white hole would repel matter and light, refusing entry. Nothing could fall in. Everything would be expelled outward. Some equations of relativity allow for such objects, and some physicists once wondered, could a black hole on one side of spacetime connect to a white hole on another, forming a cosmic tunnel? This is the idea of a wormhole, an Einstein-Rosen bridge, a shortcut through the universe. Enter through a black hole, emerge from a white hole somewhere else, in another galaxy, another era, perhaps even another universe entirely. But there's a catch. Wormholes, if they exist, are likely unstable. The fierce pull of gravity would collapse them instantly unless exotic forms of matter, strange and hypothetical, could hold them open. Still, the dream lingers. Could the other side of a black hole be a passage, a doorway written into spacetime? The beauty of this idea is not only scientific, but poetic. It suggests that every ending hides a hidden exit, that collapse may also be creation, that the dark heart of a star may be the seed of another world.
At the heart of a black hole lies a problem. Einstein's equations point to infinities. Nature, however, rarely deals in infinities. It finds a way to balance even if our current understanding cannot see it. This is where quantum physics enters, offering a possible rescue from the abyss. While general relativity explains the cosmos at large scales, quantum mechanics rules the tiny realm of particles. Somewhere, somehow, the two must meet, especially inside a black hole. One theory, loop quantum gravity, suggests that space-time itself is woven from discrete loops, like threads in a cosmic fabric. Under extreme compression, these loops resist total collapse. Instead of ending in an infinite point, the collapse could bounce, transforming into expansion. In this view, the other side of a black hole may not be a dead end at all, but the birth of something new, perhaps even another universe. Think of it as cosmic recycling. A star dies, collapsing into a black hole. Yet inside, that collapse fuels creation, giving rise to new space-time beyond our own. What looks like destruction may in truth be an act of rebirth. Now let us drift deeper into speculation. Black holes do not only warp space, they also twist time. Near their edges, time slows compared to the universe outside. For someone falling in, moments pass normally, but for an outside observer, those moments stretch into eternity. Some scientists have wondered, could black holes function as time machines? Imagine approaching the event horizon and orbiting just close enough. From your perspective, perhaps only an hour passes. But when you return to the wider universe, if you could, you might find that centuries have slipped by. Black holes stretch time like clay in the hands of gravity. In science fiction, this idea often blossoms into even grander visions. Step through a black hole and emerge not only elsewhere in space, but elsewhen in time. Though unstable in reality, the mathematics of relativity does not forbid such pathways completely. The other side of a black hole may less be a place and more a when, a passage to the deep future of the cosmos. If black holes connect to creation, could the other side lead to entirely separate realities? Some cosmologists imagine a grand multiverse, where our universe is but one bubble in an endless cosmic sea. Black holes in this view may act as seeds of new universes, each born from the collapse of a star in ours. The singularity, instead of being a destructive endpoint, could be a cosmic womb. In this picture, every black hole in our universe might contain another universe inside it, hidden, unreachable, but real. And perhaps our own Big Bang was born from the collapse of a black hole in some parent universe long ago. It's a humbling vision. When we gaze at the night sky, we may be looking not just at stars and galaxies, but at countless portals to new universes, each carrying its own laws, constants, and possibilities. The other side of a black hole, then, may not be a single place, but an endless branching tree of realities, each collapse a doorway, each singularity a beginning.
When something falls into a black hole, is it gone forever? At first glance, yes. But physics whispers a different story. In the 1970s, Jacob Bekenstein and Stephen Hawking discovered that black holes are not perfectly silent. They have entropy, a measure of disorder, and they radiate energy. This discovery cracked open a new idea. Information cannot truly vanish. According to the holographic principle, everything that falls into a black hole may be stored, like patterns etched on its surface. Imagine a cosmic library inscribed on the event horizon itself, each particle's history encoded in faint ripples. The inside may be hidden, but the surface could hold a record of everything that ever crossed the threshold. In this vision, the other side of a black hole is not only physical, but informational. It may be a vast archive where the universe keeps secrets too precious to destroy. Every star, every planet, every dream that vanishes into the dark is written into the fabric of the horizon, preserved in ways we do not yet understand. Stephen Hawking made a startling prediction. Black holes are not eternal. Through quantum effects near the event horizon, they slowly leak energy, tiny flickers of light called Hawking radiation. Over unimaginable spans of time, a black hole can evaporate completely, shrinking until it vanishes into nothing. If so, what happens to what lies inside? Does the information leak back out, particle by particle? Or does it vanish with the black hole itself, leaving a permanent scar on the universe's memory? Physicists call this the information paradox, one of the greatest puzzles in modern science. If information is lost, then quantum mechanics, our most successful theory, breaks down.
But if information survives, how does the black hole whisper it back into the cosmos? The other side of a black hole, then, may not be a place at all. It may be the slow return of secrets to the universe, spread thin across eternity as the black hole dissolves into a final sigh of radiation. Some theories take us to an even stranger frontier. In the 2010s, physicists proposed the idea of the black hole firewall. Traditionally, general relativity tells us that crossing the event horizon would feel smooth, no drama, no sudden wall. But quantum mechanics suggests another possibility, that the horizon may be a searing barrier of energy, incinerating anything that dares to cross. If this is true, then the other side of a black hole is unreachable, guarded by a furnace of quantum fire. The idea is controversial, dividing physicists even today. Some argue the firewall is unavoidable. Others believe nature finds a gentler path. For us, it is a reminder of how much remains unknown. The black hole, which seems so absolute, is still a puzzle with missing pieces. Every new theory adds another brushstroke to the picture, but the canvas is far from complete.
When we think of black holes, we imagine destruction, cosmic monsters that devour everything in their reach. But in truth, black holes also give. At the hearts of galaxies, including our own Milky Way, lie supermassive black holes, millions or even billions times the mass of our Sun. These titans shape the evolution of entire galaxies. As matter spirals into them, it forms a disk of plasma, heating to extraordinary brightness. Jets of energy stream outward at nearly the speed of light, stretching across thousands of light years. Far from being silent, these black holes roar with power, feeding and regulating their galaxies. They stir gas into stars, sculpt cosmic structures, and maintain balance on a scale almost too vast to comprehend. The other side of a black hole, in this sense, may not be hidden at all. It is written in the galaxies we see, the luminous spirals and glowing clusters, each shaped, in part, by the dark giants at their cores. Black holes remind us that the universe thrives on balance. Where stars die, black holes are born. Where black holes consume, galaxies grow. This dance of creation and destruction is not tragedy, but harmony. Just as forests need both life and decay to flourish, the cosmos requires collapse as much as it requires birth. Black holes are not mistakes or monsters. They are a part of the rhythm of existence itself. The other side of a black hole may then be this very truth, that endings are inseparable from beginnings. The universe writes its poetry not in permanence, but in cycles, and black holes are among its most powerful verses. Sometimes what lies on the other side of a black hole is not a scientific question at all. It is a human one. We gaze into these cosmic abysses and see mirrors of our own mysteries. The black hole becomes a metaphor for death, for the unknown, for the things we fear to cross. And yet, just as scientists dream of wormholes and rebirths, we too imagine that endings may hold new beginnings. Philosophers remind us the unknown is not only darkness but possibility. The other side of a black hole may be the same as the other side of our greatest challenges. Beyond fear lies discovery. Beyond collapse lies transformation. In this way, black holes do not only shape galaxies, they shape imagination. They invite us to look into the deepest dark and trust that even there, the cosmos is not empty, but full of meaning waiting to be found. Even now, black holes remain elusive. We cannot visit them, cannot touch them, and yet humanity has already found ways to glimpse their shadows. In 2019, the Event Horizon Telescope captured the first direct image of a black hole, a glowing ring surrounding darkness,
55 million light-years away. It was not only a picture, but a doorway. Proof that with patience and vision, we can make the invisible visible. Future observatories will push this frontier further. New generations of telescopes, gravitational wave detectors, and space missions will let us hear black holes collide, watch their dances, and perhaps one day even map the fabric of space-time they carve. The other side of a black hole may not be reached by ships or machines, but by minds. Every discovery brings us closer, not to crossing the horizon, but to understanding what lies beyond it in ways only imagination dared before.
Why do we wonder about the other side of a black hole? Perhaps because black holes remind us of the greatest mystery of all, the unknown itself. Human beings are explorers by nature. From crossing oceans to peering through telescopes, we are drawn toward what we cannot yet see. Black holes are the ultimate horizon, the last frontier of our knowledge, and they call to us not because we expect simple answers, but because they embody the questions that make us human. To ask about the other side is to admit that there is more than we know, more than we can yet imagine. It is to lean into mystery, to let curiosity outshine fear. In this way, the black hole does not only swallow, it illuminates, pulling us closer to wonder. Picture the universe as a vast symphony. Stars are its notes, galaxies its harmonies, and black holes its silent rests, the pauses that give the music shape. When we wonder what lies on the other side of a black hole, we are asking what happens in the silence between notes. Is it emptiness? Or is it the space where the next melody is born? Science offers possibilities: wormholes, quantum bounces, new universes. Philosophy offers metaphors: rebirth, transformation, renewal. Together they form a single truth, that mystery is not a void, but a richness, a space where imagination and knowledge meet. The other side of a black hole, then, may be less about what is there, and more about what we become when we dare to ask. The future of black hole discovery. Why humans ask these questions? The symphony of curiosity. Long before telescopes, before physics, humans looked into the night sky and saw mysteries that begged for stories. Black holes, though unseen, seem to echo ancient myths. In many traditions, darkness is not only an end, but also a beginning. The Hindu concept of Shiva, destroyer and regenerator, resonates with the black hole's dual role of consuming and creating. In Norse mythology, the cosmic void of Ginnungagap gave birth to worlds, much like the collapse of a star might seed another universe. Even in modern literature, black holes often stand as symbols of transformation, thresholds between what is known and what lies beyond. When we wonder about the other side of a black hole, we are part of this timeless human tradition to give shape to the unknown through story. In myths and in science alike, black holes are not endings, but doorways, symbols of transition, mystery, and renewal. Physicists sometimes imagine black holes as more than cosmic graves. Could they be doorways? One theory suggests that at the very heart of a black hole lies a passage, not an ending, a wormhole. If true, crossing through might lead to another part of the universe, or even another universe altogether. Of course, this is speculation, and no traveler has returned to confirm it, but the possibility teases our imagination. What if a black hole is not only a destroyer of stars, but also a bridge between realities? We think of space as silent, but black holes can sing. In 2022, scientists at NASA converted X-ray signals from a black hole into audible tones. The result? A haunting, echo-like sound, almost like a cosmic choir. So when we ask what's on the other side of a black hole, we might also wonder, what would it sound like to stand at its edge? A deep, endless vibration, the heartbeat of the universe itself.
When we imagine black holes, we picture giants devouring stars. But some scientists think there might be tiny black holes, no bigger than an atom. These primordial black holes could have formed in the earliest seconds after the Big Bang. Invisible, silent, yet possibly everywhere. They might even make up part of the mysterious dark matter that holds galaxies together. If that's true, then the other side of black holes might not be far away at all. It could be woven into the fabric of the universe around us, closer than we ever imagined.
There was a curious thought shared by some philosophers and physicists. Might black holes in consciousness share a hidden link? Just as black holes conceal information behind their horizons, so does the human mind hide depths beneath awareness. The brain processes endless streams of information, yet only a small part becomes conscious thought. Could our fascination with black holes be, in some way, a reflection of our fascination with ourselves? Some speculative thinkers even suggest that the universe, like a great mind, may use black holes as memory nodes, places where information is stored, processed, or transformed. While highly theoretical, the idea touches a poetic chord. Perhaps black holes are not only physical objects, but mirrors of the mystery of awareness. The other side of a black hole, then, could be as mysterious as the other side of our own thoughts, the unseen realm where possibility takes form before it emerges into the light. In science, we seek equations. In poetry, we seek metaphors. But when it comes to black holes, perhaps both languages are needed. Physicists speak of event horizons, singularities, entropy, and quantum fields. Poets speak of abysses, thresholds, silence, and rebirth. In truth, both are describing the same thing, a mystery so vast it spills beyond any single way of knowing. The other side of a black hole, then, could be as mysterious as the other side of our own thoughts, the unseen realm where possibility takes form before it emerges into the light. In science, we seek equations. In poetry, we seek metaphors. But when it comes to black holes, perhaps both languages are needed. Physicists speak of event horizons, singularities, entropy, and quantum fields. Poets speak of abysses, thresholds, silence, and rebirth. In truth, both are describing the same thing, a mystery so vast it spills beyond any single way of knowing. The other side of a black hole may not be something to solve like a puzzle, but something to experience like a poem, an endless space where imagination meets knowledge. And in this way, black holes are generous teachers. They remind us that not everything can be measured, not everything can be named, but everything can inspire. As vast as our progress has been, black holes remain the edge of our understanding. They are the places where our finest theories clash, where relativity and quantum mechanics both work, yet cannot be reconciled. To study a black hole is to study the very limits of human knowledge. Each discovery, gravitational waves, horizon imaging, radiation, feels like a lantern held up in a cave that stretches endlessly beyond sight. Perhaps what lies on the other side of a black hole is not only cosmic truth, but also the story of humanity's endless reaching. Our questions, our persistence, our wonder, these are the real bridges that cross horizons. Sometimes, when we ask what lies on the other side of a black hole, we are really asking about ourselves. We too face horizons, moments in life when the future is invisible, when endings seem absolute, when collapse feels inevitable. And yet, like the universe, we often find that endings are beginnings in disguise. In this way, black holes mirror our inner journeys. They teach patience, courage, and humility. They remind us that even in silence, there is story. Even in darkness, there is possibility. And so, dear traveler, we drift back from the abyss. Together we have journeyed across event horizons, peered into singularities, imagined wormholes and new universes. We have explored science and poetry, myth and philosophy, all bound by a single question: what lies on the other side of a black hole? The truth is, we do not yet know. Perhaps we never will. But maybe that is the gift of black holes, that they leave us with questions large enough to stretch our minds, wide enough to awaken our wonder, and deep enough to remind us how small and precious our place in the cosmos is. So as we close tonight's journey, let us keep that wonder alive. Let us carry the silence of black holes not as emptiness, but as music still waiting to be played. Thank you for wandering through the stars with me. Until we meet again, may your nights be gentle, your dreams luminous, and your curiosity endless. Good night.